We're asked to construct a truth table with two statements in it, P and Q. And so we start off in alphabetical order, P and Q, and we always start with a couple of trues in P, and then a couple of falses. And then we do true, false, true, false. Please learn to do them in that order. It makes a lot of things go better for lots of people, including me and you. Then here we need a not Q, and I think it's a good idea to write it down, even though it's pretty easy. It only takes a couple seconds. We negate Q, take the opposite truth values. And now it looks like we need this statement, so let's write it down. And it's kind of a promise, and the only way the promise can be broken is if the thing to the left of the arrow is true and the thing to the right of the arrow is false. So we're looking for that situation, and that will be false in our truth table. So we have it right here. We have P being true and the negation of Q being false, and so that's false. But everything else is going to be true because there are no more true P's with false Q's. There just aren't. You can look. So these if-then conditional statements, there's usually true involved. And now we need the final statement, the thing we were aiming for. And if you do it the way I suggest, the thing you're aiming for will be on the far right, which is kind of a convenient place for it. There's another way to do this that the book suggests. And if you're using it, your final answer will be somewhere else. We'll talk about that in a second. Now, this is another promise, so to speak, and the way the promise can be broken is with a true here and a false here. So let's go to Q and this statement, and let's look for a true and a false. We see a true here for Q, and we see a false here for this implication, and so that's false. And there are no more trues with Q and falses over here, and so the rest of them are true. This then represents our answer to the truth table. It's what the back of the book has as an answer, but there it is. So let's circle it to make it stand out. That's our answer. Notice, just writing down this answer isn't going to do anything. You've got to show the truth table, show your effort. Problem 21, we have to construct a truth table. And in order to do that, we need three simple statements, P, Q, and R. And so we put them in alphabetical order, and P has the first half true and the second half false, and there's 8 altogether. Because there's 3 simple statements, and 2 to the third power is 8. So then Q alternates in groups of 2 true first, and then 2 false, 2 true, 2 false, and then R is true, false, true, false, true, false, true, false. Every time you see me doing one of these truth tables that has PQR, it always starts this way. On exams, I will make you start this way by putting in the first 3 columns for you very often. So now what? Well, we need a not Q and a not R, don't we? The P is just as stands, so let's do a not R. I don't like that not. And it's just simply the reverse. And let's do a not Q. And so it'll go false, false, then a couple of trues, a couple of falses, a couple of trues. And then we need this OR statement. And so we're combining these last 2 with OR, and OR is almost always true. The only way it can be false is if there's a couple of falses. So here it's false, and here it's false, but all these others are true. because they all contain a little bit of truth. And now we need the final statement. And the final statement is one of those promises. It's one of those conditionals. And so the only way it can be false is if the thing to the left of the arrow is true and the thing to the right of the arrow is false. And so we've seen this before. This is where we're starting. We're looking for a true here, and we're looking for a false over here. So we're looking for a true here and a false here. Well, the only place that can happen is where these are false, and so it looks like the last three are broken promises, because the last three have truths here and falses here, and so those are false. But the other five on top are true. This then is the answer to our truth table. Notice the truth table is more than just the answers. I mean, writing down the answers is almost completely meaningless. I need to see that you understand what's going on. I need to see the truth table. Problem 35, we're asked if this compound statement is a tautology, a self-contradiction, or neither. And so we're going to set up a truth table and see what it tells us. Thankfully, there's no R, it's just P and Q, so we start out this way, always alphabetical order, true, true, false, false, true, false, etc. But it looks like we need a negation of Q, so let's put it in. Even though it's simple, I wouldn't skip that if I were you. And then we need this promise, so let's do that. And the only way the promise can be broken is if this is true and this is false. So that's what we look for, and we find it right here. That's the broken promise. The rest of these are true. And then it looks like we're ready for the goal. And the goal is an or statement between this and this, and the only way an or statement can be false is if they're both false, and they're never both false. So this is always true, and a truth table result that ends up always true is called a tautology. One that's always false is called a contradiction. This is an always true statement, and we're done. So on problem 49, in essence, we're asked for one row of a truth table that would have 8 rows. It would have 8 rows because there's 3 statements, P, Q, and R. And the question is, if you just want the row where P is true, Q is false, and R is false, and you want to figure out if that's going to make this compound statement true or false, is there a simpler way than making the entire truth statement? And the answer is that there is a way, and it's okay, you can do it, but you kind of have to understand some things. So let's take a look. The first thing we do is we evaluate each of these pieces. So P is true, we're given that, so not P will be false. This is R, R is false, we're given R is false right there. Or this is not Q, Q is false, so not Q is true. And R is false. Now, these biconditionals are kind of easy to remember. They're true when both sides are the same, and they're false when both sides are different. Kind of like multiplying two negative numbers. So here both sides are the same, so this biconditional is true. Here both sides are different, so this biconditional is false. But we're doing an or between a true and a false. If an or statement has any part of it that's true, it's true. So if we had made an 8-row truth table, the row that had P being true, Q and R being false would have ended up having a true. So the answer is true.